All right, so we have level 1. We want to be able to simplify square roots and cube roots of numbers. It is helpful to have a breakdown of your perfect squares, cubes, and fourth roots. So I kind of keep this note card handy. If we have 60, we take a look. This is the square root, so I'm looking at perfect squares. I'm like, you know what? Are there any numbers in here that go perfectly into 60? And offhand, the only one that I'm seeing is 4, right? 4 times 15. So we can rewrite this as the square root of 4 times 15, which is the square root of 4 times root 15. Now, obviously, I'm writing a lot of extra stuff in here. You guys do not need to write all these extra steps, but this becomes then 2 root 15 because the square root of 4 is 2, okay? Now for the next one, we have negative 3 times the square root of 225. The square root of 225, we take a look. That number is actually on here. That's a perfect square. That's 15. So for this part right here, we have negative 3 times 15, which is negative 45. The square root of 36 is the same thing as negative 1 times 36. Square root of negative 1 times root 36. The square root of 36 is 6, and the square root of 1 is what we call an imaginary number. So this is 6i, but we would just say this is a non-real solution. Okay, so you may not need to find 6i right now because we're really working with real numbers, but this is a non-real solution. Then we have the cube root of 24. Now the cube root, we have to pull out 3 numbers instead of 2. So we want to take a look at the cube root. I have 1, 8. 8 goes into that. 27 is more than 24, so 8 is the last thing I'm going to be using here. So that's going to be the cube root of 8 times 3. So that's a cube root of 8 times a cube root of 3. And the cube root of 8, again, that's 2 times 2 times 2. So the cube root of 8 is 2. And then we have cube root 3. And then the last one here is going to be the cube root of negative 54. Now this is different. This is the cube root of negative 54. And negative 54 is the same thing as a cube root of negative 27 times 2. All right, and just to give you a different visual of what is happening here, this is going to be the cube root of negative 3 times negative 3 times negative 3 times 2. So if you're taking the cube root of a negative number, that number is a real number and it does exist. So this is going to be negative 3, and then the cube root of 2 we can't simplify. So we can write this kind of like this. So we have the cube root of 27, the cube root of 2. But the reason that this is real is because it's an odd root. And if you have an odd number of negatives, then you can actually pull that out of the root. But here, to have that negative 1, there's no way for us to pull that out, and that's where we get that imaginary number.